So we've come to the last in the videos in Moles 1. In this video we're just going to concentrate on looking at the experiment to find the formula of magnesium oxide, and we're going to talk about some of the errors that are associated with that experiment. Okay, so we're on page 20 of your notes and we're looking at the experiment to find the formula of magnesium oxide. So I've got about 10 centimetres of magnesium. Just going to measure it out. So there I've got my about 10 centimetres. I'm going to give it a clean, then I'm going to take a bottle top and I'm going to put my magnesium, which I've coiled, inside the bottle top. Now what I need to do is to make a little magnesium bottle top parcel. So there's my magnesium bottle top parcel. I've got it wrapped around with some wire just to hold it in place. I'll need some gaps around the sides to let the air in, because I'm going to try and react the magnesium with the oxygen. I'm going to put that on a gauze on a tripod with a Bunsen burner, and this time I need to heat it very, very strongly. So I need to have it on a roaring flame, making sure that that little magnesium bottle top parcel is heated very, very strongly. And you can see there the gauze glowing red hot. You can see the inside of it glowing as it reacts with the oxygen in the air. You might see a few little white sparks. That's the magnesium reacting. When it's all reacted, I need to let the little parcel cool completely before I weigh it. Then I'm going to heat it another couple of times until I get to constant mass. If the mass starts going down, it's usually because I've lost some of the fine white magnesium oxide powder. So you heat it until you get a constant mass. So I've finished my experiment now, and I'm just going to use my results to calculate the formula of magnesium oxide. So I've got the mass of my magnesium, I've got the mass of my little magnesium bottle top parcel, and you should see that that is gaining weight as the magnesium reacts with oxygen from the air. As I said in the video, we should actually be heating it until we get a constant mass. But we can use this to work out the mass of the oxygen that has combined with the magnesium. So I know the mass of my magnesium and I know the mass of my oxygen, and I can work this out in exactly the same way as I did in the previous videos when I was working out the empirical formula. So I work this out in the same way as I worked out the previous examples. I get a 1.2 to 1 ratio. Now that's actually not bad for an experimental value. You could say it's a 6 to 5, but you could also say when you round this to the nearest whole number, and as this is experimental values, that's quite valid to do that. It's a 1 to 1 ratio. So we know the formula of magnesium oxide is MgO. We would say from this experiment it should be Mg6O5, but it's close enough to MgO that I'm reasonably satisfied with that experiment. So we're on the last page of your notes and we're just looking at the errors in this practical. So we've got here quite high errors due to the balance. So the reason for this is I've got quite low masses. I've only got 0.1 of a gram of magnesium and 0.127 grams of magnesium oxide. And this gives me quite high percentage errors here. So I've got a 13% error just coming from the balance. But there's also procedural errors. Now if I didn't heat it for long enough, I wouldn't have actually reacted all of the magnesium, and I would get a lower value for the oxygen than I would expect. If, on the other hand, the values increase and then decrease, it's likely that some of the fine white magnesium oxide has escaped. If I've heated it at all on a smoky flame, I can get soot deposited on the bottom of my little parcel. Now if that happens, I'm calculating not only the mass of the oxygen, but also the mass of the carbon that I've added. So there's two ways I can reduce my measurement uncertainty. I can move to a more accurate, a 4D balance, which will reduce the uncertainty of the balance, or I could use a larger mass of magnesium, and that would increase this value and therefore decrease my measurement error. There are also two possible side reactions which could be interfering with the reaction. The first one is the magnesium actually reacting with nitrogen in the air. Magnesium is such a reactive metal, and I am heating it to a very high heat, so it's possible I could get some reaction to form magnesium nitride. The other reaction that could take place is that the metal bottle top, which is made predominantly of iron, could have reacted again with some oxygen in the air to make iron oxide. So that finishes this series of videos looking at the notes for Moles 1. You should now have a complete set of notes and be ready to start the questions at the end of the pack. But before you do that, turn back to the front cover, read those specification statements very carefully. Tick off the ones that you're comfortable doing and that you know how to do. If you've got any problems, do come and see one of your teachers, either at one of the clinics, or you can drop us a message through email or contact us for a one-to-one through Teams. When you've done all that, have a go at the questions at the end of the pack. We will collect that in and mark it for you. So until then, take care, stay safe. Bye-bye.